Hello. So in this video, I'm going to discuss about the paired t-test. So one type of hypothesis test, which is generally used to test when the samples are dependent. So we had a case in the previous hypothesis testings where we have done test for the independent samples, right? So in this case, we are going to discuss about how do we test uh, the hypothesis which is related to matched sample or dependent sample, the mean difference of the matched sample or dependent sample. So the paired test is basically used to test whether the mean difference between two sets of observations is zero. So in a paired sample t-test, each subject or entity is measured twice, resulting in pairs of observations. So in this test, you will be basically observing the same subject at different point of times. Okay, so what happens uh, when you give some treatment to some subject? Okay, so your sample will be like the before treatment and after treatment, and this is a widely used method across different disciplines, especially science, social science, uh, where you have many such cases where you want to see whether a specific treatment has any impact or a specific method has any impact on the output, so impact on the subject that you're observing. So for example, you could use a paired t-test to understand whether there was a difference in managers salaries before and after undertaking a PhD, whether the salary has changed after uh, a few managers undergone or they took the PhD degree. As if you are interested to, I mean, see this test this hypothesis, the best test is paired t-test. And there is one major assumption here, which says that the pair t-test, it assumes that the differences between pairs are normally distributed. So the differences between pairs are normally distributed. So that is one major assumption, and if your data satisfies this assumption, you can go by the paired t-test analysis. So the testing procedure is similar to a typical hypothesis testing. The first step is, of course, specifying null and alternative hypothesis. The null hypothesis assumes that the true mean difference is equal to zero, uh, and you have three alternative hypotheses. One is for two-tailed test, which assumes that the true mean difference is not equal to zero, and you have upper-tailed alternative hypothesis, which assumes that the true mean difference is greater than zero. You have a lower-tailed alternative hypothesis, which assumes that true mean difference is less than zero. So you have three alternative hypotheses against one null hypothesis, which says that the true mean difference or the population mean difference is equal to zero. The second step is specifying the level of significance. This will be directly given. You can go by, typically used level of significance are 0.01 and 0.05, right? And the next step is selection of appropriate test statistics and computation of value of the test statistics. So The test statistics formula I will discuss in the next slide. It is of course the paired t-test statistics. Uh, so how to, estimate the value I will discuss in the next slide. So step 4 is, the last step is of course decision making. So the decision can be made based on two different approaches. One is test statistics versus critical value approach, where if it is a right tail test, we can see the test statistics. If the test statistics is greater than the critical value, then you reject the null hypothesis. And in the case of left tail test, if the test statistics is less than the critical value, you reject the null hypothesis. And in the case of probability versus level of significance approach, the probability, if the probability is less than the level of significance, you reject the null hypothesis. So this is the formula to calculate test statistics for paired t-test. T equal to x bar t minus mu naught divided by s, standard deviation of the differenced sample divided by square root of n, with n minus 1 degrees of freedom. So where x bar d stand for mean of the matched sample difference, and mu naught of course mean of the matched population difference, or this is the hypothesized uh, value, right? Hypothesized mean of uh, hypothesized mean difference, right? uh, Mean of the matched population difference. So ST stand for standard deviation of the matched sample difference. N stand for sample size. N minus 1 stand for degrees of freedom. So if you replace this this equation with the corresponding values, you will get the t statistics. So here is an example. In this example, a researcher want to see if a weight loss program is effective or not. She measures the weight of 9 randomly selected women before and after the weight loss program. Is there evidence that the weight loss program is effective? Test at 5% level of significance. So what is happening in this case is the subject is same. Okay, so subject here 9 randomly uh, picked people, right? So, and the first column you have weight before before starting this diet program or the weight loss program, and WA stand for weight after undergoing the weight loss program. So I will show you how to do a paired t-test manually. Uh, so once you get this table, so the next step is to find out the next, of course, if you go by the procedure, the first step is of course to specify the null and alternative hypothesis, right? So your null hypothesis is the mean difference, uh, the matched difference, mean of the matched population is equal to 0, right? Mean of the matched difference population difference is equal to 0, and you are testing whether there is a reduction in the weight, right? So it is of course a left tail test. So your alternative hypothesis will be mean of the matched population difference is less than 0. So that is your uh, alternative hypothesis. So once you specify the null hypothesis, you can specify the level of significance. The level of significance is 0.05. Okay, and next is of course replacing this equation with the formula with the values. So you need the value on the mean of the matched sample difference, right? So why it is called matched sample difference? Because you are matching the weight of the same person, same subject, before and after uh, undergoing the weight loss program, right? So you need to calculate the difference, the weight difference first. That is the first step, and find out what is the mean of this column. Okay, mean of this column difference. And you also need the standard error, right? That is that denominator basically stand for the standard error. So for that, to calculate standard error, you need standard deviation of the difference, this column, again standard deviation of this column, and divide it by the square root of n. N stand for the sample size, that is 9 here, right? It is 9. You have 9 sample. Okay, so the mean of the matched sample difference is minus 32.56. Okay, so you are basically minusing the weight after undergoing the weight loss program with sorry, from the before the weight before undergoing the weight loss program, right? So mostly you have weight reduction. Okay, and there are a few people with no weight reduction, and there is one person with in fact weight gain, right? Okay, so overall we want to see whether there is any significance difference in the uh, weight loss after undergoing the weight loss program. Okay, significance difference in the weight after undergoing the weight loss program. Okay, so your the matched mean of the matched sample difference is minus 32.56, and standard deviation of the matched sample difference is 38.08, and the sample size is 9. The square root of sample size is 3, and the degrees of freedom is 8, and standard error, which is calculated by dividing standard deviation of the matched difference by the square root of n, sample size. So you're basically dividing this value with this value, so you get 12.7 as your standard error. Okay, standard error, you got the standard error, that means you got the denominator value, and your numerator is nothing but uh, your sample difference, mean of the matched sample difference is 32 minus 32.56, and mu naught is of course it is 0, right? Your hypothesis value is 0. So anyway, you don't need not bother about this part. So basically your test statistics can be calculated by dividing mean of the matched sample difference by the standard error. Okay, and you get 2.57 minus 2.57 as the test statistics. And the next step is of course uh, identifying the critical value, right? So you know what are the requirement to find the critical value. So you need the information on the level of significance and degrees of freedom when it comes to t distribution, right? So go to the t distribution table and look for the degrees of freedom, which is given in the left extreme column, and in the first row you have level of significance, and identify the value corresponding to level of significance 0.05 and the degrees of freedom 8. Okay, so you will find it is minus 1.86. It is minus 1.86. And you can also find out the estimated probability if you just go inverse, right? Sorry, I mean if you go by the distribution, the t distribution, probability distribution table, uh, where you look for the test statistics. I mean the look for the probability corresponding to the test statistics. So I got the value as 0.02, and the level of significance is of course 0.05. So now we can make a decision based on both the approach. One is test statistics versus the critical value, another is estimated probability versus the level of significance approach. So first, if you go by the test statistics versus critical value uh, decision making approach, you can see the test statistics is less than the critical value. Okay, so if it is left tail test, I have mentioned before that if it is a left tail test, if your test statistics is lesser than the critical value, you reject the null hypothesis. Okay, and coming to the probability, estimated probability versus level of significance decision making approach, uh, if the estimated probability is less than the level of significance, then you reject the null hypothesis. So here as you can see, 0.02 is your estimated probability and level of significance is 0.05. So 0.02 is of course less than 0.05. So I mean even this approach suggests you to reject the null hypothesis, right? So what is the conclusion here? I mean there is an impact on the weight loss. I mean there is an impact of weight loss program on the weight of the people who undergone this program, right? So it is significantly different from zero. Thank you.